Welcome everyone. Welcome to the course of AWS Certified Cloud Practitioner. My name is Zubair Altaf Qureshi and I welcome you to the section 4, which covers the identity and access management, that is IAM. And this is the first service that we are going to touch in this AWS Certified Cloud Practitioner. Until now we were just doing the overview. So now this is the one of the most important services of AWS, in a sense that you actually control the users and the policies that you attach to a user, so that he can or that service can have access, granular access to that particular resource, right? So for example, you have a user that is going to be part of the finance team, and the finance team has nothing to do with the EC2 instances or S3 storage, right? So the finance team should have access to the billing section only. So you from the IAM you control that user to have access to that particular finance module only. Okay, so that is how IAM is important, and we will go through all the components in this section. So without wasting much time, let's begin. So the first slide here that I have is the overview of your IAM. So we have what we call as users. Users can be a user can be a person, okay, it can be an entity, okay, and then you have groups. Groups is nothing but multiple users. So this can be a group of sales, right? So sales, and this user is part of this group. And then there is policy. Policy is a set of rules, set of permissions. And when you have specified these permission in this rule, and when you attach this permission to this group, this automatically gets attached to this user, and this user is able to do certain things that is permitted in this policy, right? So these are the three components: users, groups, IAM, policy, and then you have IAM role. So IAM role is basically given to a service. So for example, what can happen is, just imagine you have an EC2 instance, you have a machine in the cloud, okay, VM machine in the cloud that needs access to the S3 storage. So you have a virtual machine that needs access to the storage because storage has some DB. Or anything else. You can have the database directly. You can go to the DynamoDB here directly, something like that. Okay, so it needs that access, right? So you grant it give that role to the EC2 instance, so it can have access to those services automatically, right? So that is IAM role. Then you have something called as the MFA. So this is to secure your account. Okay, we will discuss this in the further slides. Then you have the API keys, programmatic access keys. So these keys are actually used to access your AWS services programmatically. Okay, you can have access to AWS via console and via programmatic access. Okay, so for example, you have the developer team, right? They need programmatic access, so you need to assign this programmatic access role to this user who is going to be part of the developer group, say. Okay, so this user needs programmatic access. But if a user is there who is going to manage the finance, is a part of the finance team, he needs access to the console, because you can access the billing and finance related tasks from the console. So programmatic access means you can give the user access to the services through programmatic things, right? For example, shell. From the shell you can give access, or you can run some codes. So that is programmatic access. Okay, let's move on to the next slide. Hope this is clear. And the next slide is describe the same thing a bit more. So we have the so as I said, this policy, right? The IAM policy is a set of permissions. This can be attached directly to the user or to the group, or you can assign this to a role as well. So this says groups are collection of users and have policies attached to them. Yeah, so these are a collection of the users and you can attach policy to them. An IAM user is an identity that represents a person or a service. So a user can be a person or a service as well, and you can attach the IAM policy to that. But recommended is you create a group and then assign add that user to the group and then assign that IAM policy to that group. And then you have roles. Roles are assumed by trusted entities and can be used for delegation. Again, as I said, roles are used to give programmatic access to certain services. So for example, I said like you have an EC2 instance that needs access to the S3 storage. You assign this EC2 instance that role of full access to S3, and that EC2 instance will have access to the S3 storage, something like that. We will see this in the future labs. So let's move on to the next slide. So here let's start with the users. So in the IAM, I will just after the slides I will just give you a glimpse of the console. You can see the users, the roles, the policies, and the groups. Okay, so let's start with the users. What are the IAM users? Right, identity access management users are basically an entity that represents a person or service, right? And then it can be assigned an access key and secret key for programmatic access to the AWS CLI, API, SDK, and other development tools. So a user can have two types of access. As I said, you can have the GUI access, the console access, and then you have the programmatic access. So depends on the type of user it is, you will assign the type of access to that user. A password, so a password for access to the management console. So if you want to access the management console, you need a username and a password to access to the console, right? And if you want to access to the you want a programmatic access, you need the access key. Okay, when you create a user for the first time, you will get this access key. You need to save it at that time. Okay, the account root user credentials are the email address used to create the account and a password. Okay, so you have the root user and then you have the IAM users. What is a root user? Root user is basically the user who has the King Kong access to all your AWS services. So this is the user which has unlimited full access to all the services of your AWS. And to root and to log in as a root user, you will use the email address from with which you have created the AWS account and the password. So you cannot restrict a root user from doing something. So that is why we it is recommended to not to use the root account. It's better to just not share the root credentials with anyone, and not to use the root account to manage the IAM AWS. It's better you create an IAM and separate IAM user with the root, using the root account. You create a separate IAM user and grant him the full access, and then use that. So if this is compromised, for example, you can go to the root account and delete this user. Okay, so that is the reason, because you cannot delete the root user. If you delete the root user, you delete the whole account. Okay, the root that is what the next line is saying. The root account has full administrative permissions and these cannot be restricted. The best practice for root accounts: don't use the root user credentials, don't share the root user credentials, and create an IAM user and assign administrative permissions as required. Enable MFA, multi-factor authentication. Okay, so this is one thing that I want to talk about. So this is part of securing your AWS account. So this is kind of, I mean, you have the password with you, okay, and then something you know, that is called something you know, and then you have one other thing, something you have. Okay, this can be any device, any authentication key, or a software like Google Authenticator, Microsoft Authenticator, something like that. So I'm using the Google Authenticator in my account. I'll show you that. Or so this is like two-step authentication. So most of you guys, you know, you have the OTP system in your phone, right, in the banking. So that is two-step verification, right? So something like that, two-step authentication here. First you are authenticated with the username and password. That is something you know, and then something you have the authenticator, you get authenticated with that. So dual layer of security. And there is something third one is also there, that is something you are. So that is not right now supported by AWS. That is like the retina scan of your eyes, or you can have the fingerprints, right? That can be also part of your authentication. But as of now, AWS supports only two authentications, username, password, and your MFA, multi-factor authentication. Okay, next is your IAM users. Again, IAM users can be created to represent application, and these are known as service accounts. Okay, as I said, you can create IAM users as an application. Okay, you can have up to 5,000 users per AWS accounts. That is a point to be remembered. So you can create 5,000 users per account, per AWS account. Okay, 5,000. That is the number you need to remember. Each user account has a friendly name, okay, and a Amazon resource name. So you have an ARN name which will represent that user, which uniquely identifies the user across AWS. So you can just point to this ARN and instead of the user, and you will and to apply policies, whatever you want to do, you can do that using that ARN name. You should create individual IAM accounts for users. Best practice not to share accounts. As I said, you should not share. So you have an account of admin, and you have, say, multiple admins in your organization. So this admin user should not be shared by all the admins. Instead, there should be multiple admin users created. So you have, say for example, you should have a admin group, wherein you have multiple admin users added to that group. So you have admin 1, admin 2, admin 3, like that. That should be the proper way to deal. It should not be like you have only one admin account and everybody, all the admins are using that same username and password. So that is what is the this line telling you. A password policy can be defined. Okay, you can also create a password policy to a user. So password policy is nothing but you can force that user to adhere to certain complexity. For example, you can tell the user that you should have minimum of, say, 10 or 16 characters in your password, and it should be combination of your say numeric and character, alphabet and numeric. It should be capital, and small letters should be special characters, like that. So that is the password policy. I'll be showing you all this in the GUI when we will access the lab part. So next is the IAM Groups. So this is basically collection of users. That is what this line is saying. Collection of users and have policies attached to them. So that policy is actually attached to the group, and all the users part of that group will be having those policies. So you can say you have a group for developers, you have AWS admin groups, you have operations group. So all these groups will have different policies, right? So for example, that makes it easy to manage, right? So developers will have, say, programmatic access, uh, and admins will have full access because they need to manage all the resources. And operations, right, they will have, access to, say, EC2, depending on the operations they are handling. Maybe S3 if they are handling storage as well. Maybe CloudFront if they are handling the cache services and all those stuff, right? So that is the groups part. And the next line says a group is not an identity and cannot be identified as a principal in an IAM policy. Okay, so that is not an identity. That's my slide just went to the next one. Okay, that is not an identity. It's just a group. Okay, use groups to assign permission to users. So that is what I said. You just add that user to that group, and the permissions that are assigned to a group will be assigned to the user as well. Use the principle of least privilege when assigning permission. Least privilege means, as I said, the developers don't need access to the console, right? So I will not give access to the console to them. Rather, they need access, programmatic access. So I'll just give them programmatic access, and that means a user that is part of the developers will not be able to go to the IAM, right? Say S3. So that is the principle of least privilege. You cannot nest groups. Okay, you cannot have groups within groups. So for example, you have operations, and inside you cannot create another group, say EC2 operation and say S3 ops. So this cannot be the case. That is what the next line is saying. Okay, let's move on to the next slide then. So you have the IAM roles here. So that is the next part. So you can assign the roles to a certain service. So these are the roles. S3 full access. Okay, let me go back to the slide. I don't know why it's changing. Okay, roles are created and then assumed by trusted entities and defined as set of permissions for making AWS service request. So you assign this. Let me take the pen. To this service, you assign a role to a service, and then he assumes that role, and then he has access to that level of services on AWS. So for example, just take an example of a person. He has been given a role of say DC. He is the deputy commissioner of place. Okay, so he assumes that role and he gets that power, right? So that is something like that. So you actually assign this role to a service, and then that service assumes that those powers. So that service says you have full access to S3, right? So if you attach this role to EC2 instance, then that EC2 instance is going to have full access to S3 bucket or S3, full S3, okay? All the S3 buckets. So something like that. With IAM roles, you can delegate permissions to resource for users and service without using permanent credentials. Yeah. So with your IAM users, you can roles. Sorry, you don't need these username passwords. Okay, you can have what do you say? Not a permanent credentials. You can have a temporary credentials and grant them permission for a certain period of time. IAM users or AWS services can assume a role to obtain temporary security credentials that can be used to make AWS API calls. So again, this is the top one was for username password. This is for your programmatic access. So you can have API calls that can be what do you say, permitted for a certain temporary time. That is the point in this line. You can delegate using roles. Again, you can delegate the roles. There are no credentials associated with the role, password or access keys. So when you assign a role to a service, there is no password and or access keys associated with that. Just remember that. Okay, so that is the roles. Next, let me just clear this. Next is your IAM policies. So what are policies? Policies are basically set of rules, you can say, or set of permissions that is defined. So policies are documents that define permissions and can be applied to users, groups, and roles. So that is what it says. You can assign the policies to users, and you can do it to the groups and also to the and the roles, right? So you can assign these policies to all these three entities. Policy documents are written in JSON key value pair that consists of an attribute and a value. So this is, written in JSON. I can show you this in the AWS console. So they have a key value pair like the permission. Permission is the key, and say for example value is allow, something like that. So key value pair in JSON. All permissions are implicitly denied by default. Okay, so when you create by default you don't have any access to. You have to explicitly allow the users or the service the access that you want to grant them. The most restrictive policies applied. So it's like by default everything is denied, and then you permit certain services. So this is the most restrictive policy, because you first of all you deny everything, or it should be the other way around. You permit certain thing, and then whatever you don't permit gets denied by default. So that is implicitly denied. Implicitly denied. So yeah, so that is the restrictive policy. IAM Policy Simulator is a tool to help you understand, test, and validate the effects of an access control. So you have this tool, simulator tool, which you can use to test the policy. The condition element can be used to apply further condition logic. So you can have this condition in element also in the policies to define access or block access to the certain services or access to the console, whatever you want. Okay, you can do a lot of things using the IAM. So this is just the beginning. When you have your hands on, you will learn a lot of things. So next is the authentication method. That's what I said. The authentication method will have the IAM user who has access to the console, and he can have access to the what do you say, the CLI, or you can have the programmatic access. So that is what you have, this access key and the access key ID. So here I want to show you that same thing. So if a user who is a developer wants to have developer, he wants to have programmatic access to the AWS service. So he should have this AWS key, and while you create a user, you get this access key and access key ID for the programmatic access. If you enable that for programmatic access option, I will show you that in a moment. So consists of an access key ID and secret access key, and is used for programmatic access. So you should know this programmatic access, who needs this access and who doesn't, right? So a developer might need this programmatic access, and then he should have this access key. And then he uses this access key to make an API call to that service. MFA protection can be added to API operation. You can add the multi-factor authentication here as well. So so somebody who wants the AWS management console, say an admin, he is an IAM user. He has the username and password. He logs into the AWS console, and also you can enable the MFA here. Third thing, you have the signing certificate, and not all services support it, but some of it does. Okay, let's clear this slide and let's move on to the next slide. So this is about the access key. So some points related to the access key. A combination of access key ID and a secret key. So I'll show you this. You have the key ID and the access key. These can be used to make programmatic calls to AWS when using the API in program code or at a command prompt when using the AWS CLI or the AWS PowerShell tools. So you are using the CLI in this, and you are getting the programmatic access via using this secret access key. You can create, modify, view or rotate access keys. You can do that, and when created, IAM returns the access key ID and secret key. So when you create a user, you will get this access key ID and secret key. I'll show you this in a minute. The secret access is returned only at creation time, and if lost, a new one must be created. So this is what you need to remember, because at the time of the creation, when it returns you to the access key and the secret access key, you need to save that at that time. If you don't, then you don't get access to the access key again. So in that case, you have to again create a new user. Ensure access keys and secret keys are stored securely. So you need to save them securely somewhere so that nobody else will have access, or if someone else will have access to those secret access keys, they can they can do you a lot of damage. Okay, users can be given access to change their own keys through IAM policy. So you can change not from the console, you can change it through the CLI. You can disable a user access key which prevents it from being used for API calls. Yeah, you can do that, enable and disable that access key. So that is the IAM access keys. Let's move on to the next slide. So this is about the console password. So for the management console, to access the management console, you need a username and a password that the user can enter to sign into interactive sessions such as the AWS management console. So that is what you need. You can allow users to change their own password. Again, you can allow the users to change your own password. So you are the so this is like you are the root user, and you create multiple IAM users, and those IAM users, they have permission to change the password. Okay, to change their own password. But you also have permission. You have King Kong permission. You can delete them, right? So that is not what I am talking right now. So we are actually talking about these guys, IAM users. They have access to change their passwords. You can allow selected IAM users to change their password by disabling the option. Okay, you have the option. The root users will have the option to disable this feature. So when you grant this IAM user username and password, you disable them to you will be disabling them so that they cannot change the passwords, right? Okay, then let's move on to the next slide. This is for the IAM server certificate. So this signing certificate. So you can have the something like a CA server. So you can sign the certificate and then send it to AWS. SSL TLS certificates that you can use to authenticate with some AWS services. So you can provide these certificates to that services, and they can authenticate using these certificates. AWS recommends that you use the AWS Certificate Manager ACM to provision, manage, and deploy your server certificates. So you have this ACM service that you can use to provision and manage and deploy your server certificates. But the problem is not all the services support this ACM. So you can see in the next line, use IAM only when you must support HTTPS connection in a region that is not supported by ACM. Okay, so let's move on to the next slide. So you have the multi-factor authentication. How it works, as I earlier said, something you know, that is your username and password. Something you have, that is your authentication, whether it be a physical authentication tool, or you have the virtual authenticator like a Google Authenticator. And then the third thing is something you are. It can be the biometrics or your retina scan, like that. So as of now, AWS has these two. The something you know, username, password, and something you have is the virtual authenticator, something like Google Authenticator, or a physical MFA device, right? So you can use this to strengthen the security of your account. And you have the AWS Security Token Services, STS, By default, this is enabled on all the services. The AWS Security Token Service is a web service that enables you to request temporary and limited privilege credentials for IAM users or for users that you authenticate. So you can give these tokens to the users who need temporary kind of access to certain services on your AWS. By default, AWS case is enabled as available as a global service, and all AWS STS requests go to a single endpoint at this URL. All regions are enabled for STS by default but can be disabled. The region in which temporary credentials are requested must be enabled. So you need to enable that region for STS. Credentials will always work globally. So it's not regional, it's global credentials. Okay, so the best practice, before we wind up the IAM section, I just want to go through some of the best practices of IAM. Lock away the AWS root user account keys. Yeah, so that is okay. Let me grab my pen. Okay, lock away the AWS root user access. As I said, just don't use the AWS root user to create and manage other services. Instead, just lock this AWS root user and create a new IAM user which has the full access to all the services, and then from there you can create more users. Create individual IAM users. Okay, use AWS defined policies to assign permissions whenever possible. So you have tons and tons of policies that are predefined. So this is what it is saying. Use those policies instead of defining by yourself. Use groups to assign permissions to IAM users. Sorry. So instead of assigning permissions to the users, add the users to the group, and then assign the permission to that group. Right. So that is the best practice. Grant least privilege, as I said. So if someone needs a developer permission kind of thing, give them only that permission. Don't give them access to EC2 or to the storage, something like that. Use access levels to review IAM permission. So you can use the access level to review the permissions, IAM permissions. So you can view these access levels. Configure a strong password policy for users. So you can manage the password policy, right? You can force that user to say use 16 characters, alphanumeric and alphabetical. So alphanumeric, and then you can use special characters, something like that. And enable MFA. Best thing to do. Use roles for application that run on AWS EC2 instances. So as I said, for example, you have the EC2 instance which needs access to the S3, so you assign that role to the EC2 which says full access to S3, full S3 access. So like that you can assign. And delegate by using a role instead of sharing credentials. Yeah, instead of sharing credentials, you should delegate the roles to that EC2 instance. Rotate credentials regularly. Okay, and remove unnecessary credentials. So credentials that are not used, just delete them. Use policy conditions for extra security. Monitor activity in your AWS account. So you can use this. You can monitor the activities done by users. So that is it for the IAM best practice. One thing that I forgot to mention in the earlier sections was the shared responsibility model. So this is a very important part of your AWS Cloud Practitioner. I just want to go quickly through this. So this actually defines what is your responsibility as a user and what is, or a customer, and what is the role and responsibilities of AWS. So on premises, you can see if you own a data center, if you own let me go back to my slides and pen. Okay, so if you own a DC, so this is the left one is a DC. So from top to bottom, everything is managed by you. So you will be responsible for all this, right? By you as an organization. Applications, data, runtime, middleware, OS, licensing, VMware, virtualization, whether you are using KVM, Hyper-V or VMware, whatever you need, you will be maintaining that. Servers, the hardware you buy, right? Whether it's a Dell, HP, whatever. Storage you buy, Seagate, Barracuda, whatever you want. Networking, then again, whatever cabling you want to do, the devices that you want to use, all of this is managed by you when you own or manage a DC. But if you go for IaaS, that is infrastructure as a service, so this part is managed by the cloud provider. Okay, the green part is managed by the cloud provider in the IaaS. So you manage only these things, and the virtualization part, server part, storage part, networking part is the responsibility of the service provider, whether it's Microsoft, Google, or AWS. Then you have PaaS, platform as a service. So in that you can see from here, from the runtime to the networking, everything is managed by your provider, and just the application and data is managed by you. And if you go for SaaS, software as a service, top to bottom, all the stack is managed by your service provider. So yeah, from left to right you can see the difference. So that is what I was missing in my previous sections. So I just quickly wanted to cover this so that you don't miss these important stuff. So that's it for this video, guys. Stay connected for my future videos, and if you like the content on my channel and the way I teach you, please do subscribe to my channel, share, like, and comment as much as possible. Thank you, guys. Thanks for the love that you are providing to me. Thank you. Bye bye.